the story of an ordinary girl with a desire to learn. It's so cold. I'm so tired. I'm just gonna lay down for a couple of minutes. You must take an iron supplement capsule daily. But why? Why do I have to take these stupid pills? The formation of anemia. Erythropoietin is a hormone released by the kidneys. It ultimately instructs the bone marrow encapsulated in the bone. More specifically, it's the hemopoietic stem cells in the bone marrow that form red blood cells. These red blood cells contain hemoglobin, and hemoglobin is the protein that binds to oxygen. Pause. Let's quickly look at the forces involved to make this attraction possible. Here, the attraction that occurs is due to an intermolecular force between the oxygen atom and the hemoglobin. Since the hemoglobin contains multiple intramolecular forces, such as ionic bonds, hydrogen bonds, and London dispersion forces, the entire compound has shared polar and nonpolar characteristics. It is also thought to be positively charged due to the gas exchange process. On the other hand, oxygen, a diatomic molecule, has an equal sharing of electrons, thus making it nonpolar. It is also thought to be a negatively charged atom. Therefore, this explains the tendency or urgency for the oxygen to bind to the hemoglobin, because they form an intermolecular force called an electrostatic attraction. This occurs between two oppositely charged ions, in which they bond while alternating charges. Since an electrostatic attraction is one of the stronger intermolecular forces, it proves why and how oxygen is able to spread throughout the body to all cells. Wait a minute, there has to be more to this. In a healthy human, an erythrocyte contains 4 iron ions. Each ion will have the ability to attract an oxygen molecule. This produces a new molecule called oxyhemoglobin. The balanced chemical equation looks like this. Hemoglobin is in the solid state because it is a protein made up of long amino acid chains, which essentially makes up a solid material. This takes on the form of a synthesis reaction, which is when two substances combine to make one new substance. So let's quantify this reaction to really grasp the concepts. What is the mass of the oxyhemoglobin yielded if excess oxygen gas combines with 500 grams of hemoglobin? Since we know the mass and molar mass of hemoglobin, we can find its moles by using the relation moles equals mass over molar mass. Then, we can divide up by the coefficient of hemoglobin, then multiply across by the coefficient of the substance that we are trying to find, and ultimately get amount in moles. And since we know the molar mass, we can find the mass by using the relation mass equals moles times molar mass. Notice how the mass that has been yielded is almost the same as the mass that was input? This is because of the law of conservation of mass. In a nutshell, it focuses on the system's consistency in mass during the entire procedure. Since oxygen is a gas, the 0.6 grams extra is ultimately just the weight of the oxygen. Now, with someone who is anemic, their heme in their hemoglobin starts off with a smaller quantity of iron ions. So how much oxyhemoglobin will be produced? If we start with 20.98 grams of hemoglobin and repeat the same stoichiometry calculations previously used, we get 20.98 grams of oxyhemoglobin produced. In this case, we get the same mass yielded because we start with a very small mass. Thus, the addition of the weight of the oxygen is insignificant and unapparent using only 4 significant digits.
This draws our attention to the fact that we must recognize, physically, the body has produced less oxygenated red blood cells as it started with less hemoglobin, which will have the adverse effects on the patient, such as fatigue and dizziness.
Now back to you, Doc. Hemopoietic stem cells become immature red blood cells. These red blood cells are called erythroblasts. Next, these immature red blood cells become mature red blood cells. These mature red blood cells are called erythrocytes. Ultimately, anemia is the low count of red blood cells. For example, if someone has renal failure, they lack in the production of erythropoietin. Thus, it regulates the entire cycle of the formation of red blood cells. The heme in hemoglobin that is contained in red blood cells produces the iron for the body. But if there is a problem in the formation of the hemoglobin, then an iron deficiency anemia manifests. This also gives rise to the fatigue a patient might feel because the cells in the body are simply not getting enough oxygen to survive. Causes of anemia include decrease in iron intake, increase in body's demand for iron, which is found in teens and in pregnancy, decrease in absorption of iron, and an increase in blood loss, which can come from peptic ulcer disease. Iron supplements may be taken orally through a small capsule of ferrous sulfate or ferrous fumarate. This essentially increases the amount of hemoglobin in a red blood cell, thus regulating the ability for oxygen to circulate throughout the entire body. Now here's an example of a normal attraction between oxygen and a red blood cell, or more specifically, the hemoglobin found within it. Now here is the same demonstration with someone who's anemic.
As you can see in the second demonstration, there is less hemoglobin binding to oxygen, thus not allowing enough oxygen to circulate throughout the body.
Oh, I get it now.
Oh, and I forgot to mention, make sure you only have one capsule daily.
That was a close one.